Hello everybody, how's it going? It's me, Tim Dodd, the Everyday Astronaut. It feels like it's been a long time since I've been able to stream. I think I missed 4 opportunities to stream when I was gone for a little vacation. Not too bad, 2 of them launched, so we're still here with several other launches that are starting to happen. So the first one today is the New Shepard. This is Blue Origin's New Shepard vehicle. Their live stream has already begun, so I'm going to fly through our pre-launch preview for you guys so we can kind of tell you what's going on so I can listen in on the webcast and see if we can learn anything new. So just bear with me. We're just going to kind of go through this pretty quick. Oh, look at that. It's my face all covered up by a thing. All right, so this is the New Shepard NS-13. This is their 13 launch of the New Shepard vehicle. Going to be taking off today in about 30 minutes, as you can see. This is, again, NS-13, and they're including a key test for NASA's landing technology. The launch provider is Blue Origin. The customers are NASA and also private corporations and some universities as well. The rocket is New Shepard NS-3, so it's their 3rd New Shepard. This is the 7th launch of this suborbital rocket. The launch location, Corn Ranch, Texas. Payload mass, we don't know. The spacecraft is only going suborbital. This only goes up, then back down. Takes about 15 minutes. No big deal. Just barely crosses the Kármán line, but gets about 4 minutes of nice, clean zero gravity. Weather's looking, we don't know. They will attempt to recover the first stage. That's how the New Shepard operates. They will be landing the first stage just about 2 miles or 3.3 kilometers away from the landing pad. They're right there, all out there in the middle of Texas. There's no fairings on this bad boy, and there's no fairings on this bad boy. This is the 13th launch of New Shepard, 7th consecutive flight for this booster, which is, of course, their record. So, yeah, if you want to learn more about this, you can go ahead and go over to everydayastronaut.com, click on pre-launch previews. We have kind of all of the stuff, including this cool landing, the light detection and ranging LiDAR. So basically, it's LiDAR that's going to help them land on the moon eventually. So check all this out by going to everydayastronaut.com/pre-launch preview. But I'm going to hop over here and listen in.
This particular booster. So we're excited about that, as well as all the great experiments that we have flying on this for the first time.
Awesome, awesome. Well, we have 12 commercial payloads on board today, and one notably, of course, is our first experiment to ever fly on the booster. So could you tell us a little bit about that? Yeah, glad to. In addition to getting all the kind of experience that we want to go fly humans, which we're getting very close to doing, we've flown over 100 different payloads on New Shepard. This one is a little bit different in that we're actually going to be flying not only in the crew capsule, but also be flying actually on the booster itself. And in this case, we're going to be flying some lunar lander sensors, some sensors that give us some great understanding of how we do precision landing on the moon. This is something different than what we've had in Apollo, where they didn't have those technologies. Now we can land very closely and position things all in one area. So it's an exciting ability to use that New Shepard vehicle as a test bed, so it does many of the same things as what you see behind you there with a lunar lander. It's a great day for us to actually try that new type of experimentation on the outside of the booster. So Bob, any final words for Team Blue as they prepare for launch?
Well, I'm looking forward to the launch. The team's well prepared. The vehicle's in really good shape. We look like we have really good weather, so we should be off and ready to go. So I'm excited about the next launch, and we'll talk to you after we get done.
Awesome. Well, thank you so much for your time, and good luck down there, and Godspeed, New Shepard.
Great. Thanks, Caitlin.
Thank you.
Get out of there, Playbar. What's going on?
Great to hear from Bob as always. And now let's get into today's launch. So on last launch, we flew our 100th payload. Congrats, Team Blue. That's a really big accomplishment. We're building on that manifest today with 12 commercial payloads, 8 of which are from NASA's Flight Opportunities Program. Most notably, we're testing precision lunar landing sensors on the New Shepard booster. So excited to see this experiment fly, Joel.
Incredible.
It's all part of the Tipping Point partnership with NASA, and also the first ever experiment to be mounted on our booster, as Bob said. So this represents an important step testing technology to land on the moon, as we're essentially using New Shepard to simulate a moon landing. How cool is that?
I love that. It's really cool. And of course, also true to our step-by-step kind of approach that we do here, today's launch also has a direct tie-in to our New Glenn program. And what we've done is actually we're installing a special kind of new heat shield on the aft portion of New Shepard that we're going to be testing for New Glenn flights in the future. So that's pretty cool. And we're going to look forward to seeing the results of that as well today.
Well, today is just a step-by-step flight. We're testing technologies for the moon, for Blue Moon, and testing technologies for New Glenn. What a great use of this suborbital platform.
That's right.
And we understand here from Mission Control that everything is looking green and go for launch. All right, we're getting excited. So why don't we go over the rest of our manifest of what's inside the capsule?
Awesome. Today we have a technology demo on board, Caitlin, from Space Lab Technologies called Micro G Lily Pond.
I love that name. That is a really cute name.
It's a really good name. They're going to be performing research that's going to optimize the future growth of plants in space without using soil. Very cool. We also have a payload that is reflying from NASA's Goddard Space Flight Center. And that payload is gonna help us to learn how to advance technology that's meant to keep electronics from overheating while in space.
I don't know about you, but that sounds really important.
Exactly.
Another one I think is really cool is called BOR 2, or the Box of Rocks experiment.
That sounds
So if you're
great.
gonna use an acronym, make sure that it's a fun name. That's a new rule. They're testing a small, cheap device that could make samples could take samples magnetically from near-Earth asteroids to test their composition. Super important for the future of resource utilization in space when millions of people are living and working there. Lots of different types of asteroids and materials out there we can use. And as Joel mentioned earlier, some of our customers today have been with us for several flights. Thank you so much for flying with us today again. Some are reflying, some have been with us for 3, 4, even 5 flights. And what they really say they love about New Shepard is it's a platform that you can easily iterate. You know, you can go fly again, either, to advance your science or technology suborbitally or your commercial application, or you can take, your testing that you do in suborbit all the way to the ISS or even on a planetary mission. So it's just a really great platform for that. All right, let's check out the clock here. We're at T-minus 23 minutes and 50 seconds. Weather in West Texas, we're hearing, is still great for launch today, which is awesome for those sensors. They need a clear day to really do their work. So let's go back to that key payload on today's launch, the lunar landing demo. So as we noted, it's the first experiment on a booster, and we wanted to show you a quick video to explain a little bit more about how the technology works from those brilliant engineers at NASA and Blue Origin working on it. So let's roll it.
Tipping Point is a payload that we've been working together between Blue Origin and NASA, so it's really interesting collaboration.
So I wanted to kind of, even though this is actually the stuff that I want to hear and learn about, I do actually want to talk to you guys about a couple things, because I think there's still a lot of questions about, I guess, how they're operating, why they're operating. People, you need to understand that this booster is basically a way that they first learn a lot of technologies. But second, is like we're seeing on screen here, it's a way they're going to be demonstrating and working on propulsive landing, all that stuff. But the cool thing is they'll eventually be able to pay for the development of this rocket by selling seats on it. So unlike SpaceX when they did the Falcon, the F9R, and the Grasshopper vehicle, which were their demonstration vehicles to practice hopping, they couldn't really, make any money. They couldn't profit off that. They didn't use it as a test platform other than literally just going up and down a couple times. Well, dozens of times, in order to practice landing. Blue Origin, on the other hand, decided, hey, we're going to use this as a platform to learn how to work with liquid oxygen, liquid hydrogen, liquid hydrogen is very hard to work with. But we'll also use it as a test bed to be able to learn how to propulsively land, learn how to work on ground systems, learn how to just kind of get their feet wet. And they're going to be applying a lot of this technology to New Glenn. which, by the way, if you haven't noticed the naming scheme, New Shepard, Alan Shepard, first human from the United States to fly suborbitally. This is a suborbital rocket. John Glenn was the first American to go into orbit. So New Glenn is their first orbital rocket. And New Glenn will be massive when it flies. It'll be more capable in a lot of ways even than Falcon Heavy. So their first orbital rocket is going from non-existent to more capable than Falcon Heavy in some cases. And it's a reusable first stage as well. So they're really going up. They're going from like 0 to just cranking it up to 11. If you haven't, people think, oh, I don't think they'll ever do it. Just go out to Cocoa Beach in Florida. Just take a look and see their launch pad out there. It takes up the entire coast. It is absolutely massive. It's insane. They have billions of dollars invested already in that launch infrastructure. It's the biggest thing you can see from the public beach there. So here, I'm going to listen in here real quick again, and then I'm going to get to some of your guys' answers. I do need to say real quick, thanks to John Beert, who asked if something is possibly top secret in your opinion, you can't discuss it, can you? I can discuss anything. Ooh, Bridenstine. Hold on. We got to hear Bridenstine.
Why is going back to the moon so important?
Well, there's so much left to learn about the moon, and not just how much we can learn, but also what we can do from the moon that advances science. The moon represents heliophysics, the study of the sun, astrophysics, the study of deep space. It also represents planetary science. We need to go to the moon so that we can learn how to live and work on another world for long periods of time because we have an agenda to get to Mars. And we're very excited about all of these opportunities.
Well, how are our commercial programs, suborbital programs like New Shepard, helping NASA achieve its missions?
It's critically important. So the way it's been for decades now is you have to go all the way to orbit the Earth. And of course, that's tremendously expensive to launch a rocket to the International Space Station, dock, and then do your experiments there. But if we could launch suborbitally and have maybe 5 to 10 minutes of microgravity where we can actually test technology and do training and do scientific experiments, and the fact that, we have these commercial providers like Blue Origin that can fly into suborbital space and help us test these technologies. It's an amazing relationship, and of course, critically important to accomplishing our mission.
Well, at Blue Origin, we have kids draw their visions for the future on postcards, and we're going to be flying those on New Shepard along with the other payloads. I'm curious, if you could draw on one of those postcards, what would you put? What is your vision for the future?
Well, I'll tell you this. I would. There's no question. I would draw my family. Most important thing in my life is my family. The challenge is I might have to draw them as stick figures. My artistic capabilities aren't quite there, but I would definitely put my family on a postcard and send them to space and dream about a future when humanity is going to be living off the Earth.
Thank you so much for joining us. We really appreciate it. It's been a pleasure, and thank you as always for your support.
It's been my pleasure, and let's go New Shepard. Let's get this mission accomplished and see what great things come from it.
You can just really see how passionate.
So really quick, I wanted to continue answering the question from John Beer, asking about if anything's top secret, in my opinion, saying, can I discuss it, basically? And the answer is, unless I've been told not to discuss something, unless I've signed a non-disclosure agreement to something, I can talk about anything. I can talk about anything I want. That's the beauty of not working for anyone. People always ask if I'd want to work, for SpaceX or, work for, Blue Origin or whoever, insert name there. And the answer is no, I don't want to work for anyone because I can talk about whatever I want. I can talk about things that are, that people see at Boca Chica. If someone takes a picture or something, I can discuss that openly and just sit there and just kind of guess with you guys along and make predictions on what that might be. Obviously, if I have something that is sensitive information and I'm told not to share it, I obviously can't share that. But as far as if, in my opinion, even if it's top secret and it's publicly disclosed or something that's been speculated on, then of course I can weigh my opinion on that, and talk about it. So, that's just kind of how I tend to go about things. So, David Willis saying, not really a pointy end up today, huh? Well, that actually brings up, I do have a new Shepard model here. And you're right, it's not exactly the pointiest top. It's rather phallic in nature, but it's designed for a purpose. And yeah, it's really, honestly, I think it's a cool design, because what they did with this ring here, this is almost like their grid fins. It's basically a stabilizer. Air can flow through this section up here. Once the capsule detaches, it's actually like, it's basically like a bunch of fins, and they even have air brakes that pop out and extra fins. It's actually a really cool, elegant design, and I've never really seen anything else like that. But yeah, it's you're right. It's not necessarily a pointy end, but it's more of a gently rounded. I have no idea. I don't know how to describe shapes and things. Let's see here. Innocent Raptor, how's it going, man? We have Team Space, yes, but what about Team Dodd? We're all Team Space, and I'm Team Dodd. I don't know if we need Team Dodd. I think Team Space works perfectly great. Thank you, Innocent Raptor. Love you, man. How's it going? Loritz Frill says, hey, Tim, have you seen Mr. Beast's latest video? In the end, there's a guy holding a sign saying moon while wearing a SpaceX hat. Please take a look. I am familiar with this. I got tagged on Twitter about 100 times. Yeah, it is. That's a fun speculation. I could absolutely see him being chosen for Dear Moon. I mean, he has one of the biggest reaches on YouTube, and think about how many people he could reach and tell his story, and how life-changing it'd be for someone like him to do Dear Moon and to experience space flight and make videos about it. I mean, I think, everyone has an opinion about, who should do what in that sense, but at the end of the day, someone like Mr. Beast that, obviously has what it takes to make a viral video, obviously has what it takes to share his experiences and have a huge reach. I think that'd be really cool. I would love to hear more about it. I hope we do hear more about it pretty soon. I'm going to listen in here real quick.
New location for our customers that they can use to expose their experiment to the space environment. So let's take a look.
Oh.
Hey guys, I'm here in our Kent, Washington headquarters in our factory where we build New Shepard. And I want to talk about our exciting payload on NS-13 from the NASA Tipping Point program, the Lunar Landing Sensor demo that we're going to put on our rocket. This demonstration is really important because in order to go back to the moon to stay in a sustainable way, we need to be able to precisely land cargo and even people on the lunar surface in a specific location. So New Shepard is essentially 4 pieces. It's the crew capsule on top that holds the 6 astronauts on their way to space and back. And then the booster is about 3 big pieces. You have on top the ring fin. In the middle, the biggest part is the tank that holds the fuel. And then on the bottom is the aft portion, which houses the avionics and also the engine. This is the ring fin. It's the very top of the rocket. It sits on top of the booster, and it essentially cradles and holds that crew capsule with the astronauts.
I think that is so cool.
So the star of the show for NS-13 is our Lunar Landing Sensor demo. I'm going to show you where it's mounted.
Yeah, when you look up, you can see through, and it's aerodynamically stable then. I think that's awesome.
This is where we'll mount the LiDAR sensors. And on the interior of the ring fin here, and on the top of the LOX tank of the booster, we have what we call the dance floor. And it's a really great location to put avionics for any type of sensor experiment you're going to do on New Shepard. So the reason that we put it on this component may or may not be obvious, but because it juts out a little bit from the rocket booster, it means that the sensors can look back down and have an unobstructed view of Earth, so they can send their signal, receive it back, and then calibrate their location. So now that you've seen the sensors, you can tell that we're basically using New Shepard to simulate landing on the moon. I think that's pretty cool.
That is pretty cool. That's a nice little tour you took us on there, Caitlin.
Thanks, it was fun.
All right, everyone. Thank you for joining us live today. We are now at about T-minus 12 and a half minutes until New Shepard's 13th launch to space. Caitlin, this is actually the 7th launch for this booster, isn't it? And this capsule.
That's awesome. So that is a record for this vehicle. Great job, Team Blue. I mean, that is real operational reusability and work.
That's right.
All right, so let's take a look at the star of the show, New Shepard, as she gets ready to go to space.
Sweet. At one point, they had to install some shades exterior, like big just shades to make sure that when you're inside there, you're not just getting cooked. Of course, no one has flown on New Shepard yet. I really hope we hear an update on when people will fly on this thing and when they're going to start selling seats and for how much, because we still don't have those answers.
And we're just minutes away. So let's take a deeper look at the mission profile for today's launch.
Okay, the mission profile is pretty simple. You go up, you come back down. So let's keep answering some questions here. This is a good one from Her Lucky wants to know, do I prefer SpaceX or Blue Origin and why? Greetings from Switzerland. Love your content. Well, for those of you that know me, you'll know my answer is gonna be Team Space. I'm Team Everybody. I'm really excited to cheer on anyone working on space flight. I just think that's an awesome thing to be working on. And but I do have to say, obviously, I think we all will have a favorite. And the whole point is, I guess, it's of course okay to have a favorite. Everyone has a favorite and everything, but it's to not poo-poo on the other people working on it too. I'm obviously a huge SpaceX fan because of how much they've done in such a little amount of time, especially in the past 5 years. You know, when we look at their first landing on December 21st, 2015, we're coming up on the 5-year anniversary of landing an orbital class booster for Orbcomm 2. Booster 10.19 or wait, booster B1019, no period. There we go. I knew I had it in there somewhere. Yeah, when think about how much has changed since then. There's been Falcon Heavy, there's been reuse galore. We're seeing Starlink rolling out. We're seeing all these cool things happen. But what I like about, what I really prefer about SpaceX is that they bring us along for the ride so much. Oh, there's those shades I was talking about, by the way. You can see the giant shades to block the sunlight from cooking up the inside of the capsule. But the thing that I like is how open SpaceX is. It makes it really easy for us fans, for us adoring just onlookers to be able to get a sense of where they're at in progress, watch along with their successes and failures. And no other company does it like that. I would say that, yeah, no one else is like that. No one else is out there answering very intricate questions in real time like Elon Musk does. So it's just really easy for us to get excited about what they're working on because we see it so closely. We get to watch it so closely. I would love for some other aerospace companies to take more of that approach. I know that, Blue Origin's the opposite of that. They're like, literally, you don't know they're doing something until it's, at best a day beforehand. So it's kind of hard, but that's one of the things that I think that's one of the big reasons why I like SpaceX so much, and that's why I think a lot of people like it. It's just because we get brought in for the ride so much. But hopefully Blue Origin. Let's see if they're going to talk at all about when they're going to fly.
The crew capsule sits on top of the booster for its flight up to space. But why don't we check out what's inside the capsule? Now let's look at some of the key features, starting with the seats, of course. So these seats are in-house designed seats based on a helicopter model. They're made through the scissor mechanism to be able to take out any extra forces, downward forces, as you come into land. The other thing that you cannot miss when you come into the crew capsule, of course, are these big, beautiful windows. These are the largest windows that have ever flown in space. In fact, over a third of the capsule are windows. 6 seats, 6 windows. Everybody gets a window seat. Next stop on the tour, the window sills. You see, anything in the capsule that's noted as blue is what you can hold onto as you're floating around the capsule up in space. Last but not least, we've kitted out the crew capsule with a lot of cameras. We want you to be able to share your memories with your loved ones for years to come. What's so wonderful about the New Shepard system is whether you're a tourist like you and me and you want to go explore the stars or see your home from space, or you're an astronaut that works for NASA or another space agency, New Shepard's going to be your ride.
I do love those big windows.
Really putting Ariane to work today, aren't we?
Yes, we are.
Caitlin, as you know, we're actually getting really close to flying humans on New Shepard, which is very exciting. And we've been working very hard to verify the system and have just a couple more flights before we start to put humans on board.
We're getting really close, and today's flight will be another step. And to prepare also, we've been doing astronaut rehearsals and going through the motions for launch day in West Texas. And actually, Joel and I were lucky enough to be a part of these rehearsals. Really was just a trip of a lifetime. we went through all the motions and all the details of our astronauts' trip to space. And I'll never forget the feeling, just like you can see here on screen, of walking across the gantry, you know, rocket or not on the pad. Once you get up to that tower, your heart starts to beat and you just feel like you're about to go to space. And then you get in that capsule, you sit in that comfortable seat, put your harness on like you can see those astronauts doing there, and they close the hatch and it's just you and your 5 best friends on that rocket getting ready to go. And I will just never forget that feeling. I was ready to go to space.
I was ready to go as well. The most distinct memory, I think, for me was just sitting in the capsule and awaiting terminal count as you watched the mission control team and the tower crew do their final preparations. It was all just very, very real, and letting those moments really kind of sink in, and listening to the sights, listening to the sounds, and watching the sights out the window. There was something very surreal about it, and you become very contemplative as you're looking out the window and thinking about this event that you're going to go through that is really going to change your life.
Yeah, and I think, you know, we have Capcom, who we were talking to at that time.
Yeah.
They had a couple space jokes to kind of calm your nerves, which really helped. We're working on the jokes, but they were really good.
Yeah, you can talk right to mission control.
Yeah.
They do a good job putting you at ease and keeping you connected to the mission, which was really, really good to experience.
Yeah, it was awesome. All right, and of course, you know, just as Apollo and the shuttle inspired so many of us to explore space, we're hoping that spaceflight today inspires the future generations. And that's why Blue Origin founded our nonprofit Club for the Future, and we have a payload on board from them today. We have tens of thousands of postcards from the club, from students all around the world. This is our second flight for postcards, and some of the postcards flying today even have a special Artemis stamp. So thank you, NASA. That is such a great keepsake for all of these students. And I want to do a special shout out to my nieces and nephews. So hi, Colin, hi, Kinley, hi, Fiona, hi, Bridget, hi, Cole, all future astronauts, of course. And another special shout out to Cedarhurst Elementary in Highline Public School District in Burien, Washington. Yeah, stone's throw from Joel's house. You know, before COVID, we were able to visit the school and made postcards with the students. Their ideas for the future of life in space, I have to say, were awesome, but also brilliant and smart. I mean, these students are really thinking about what will be possible in the future. And one idea I really liked was a trash collector in space. So,
of course,
as we all know in the industry, there's lots of orbital debris up there already. So very important. Hopefully it's a recycling trash collector. And another one I thought was really fun was using asteroid water to fight fires on Earth. So definitely something we could have used this year, but just really innovative ideas from the students.
Yeah. I mean, these are some just really great examples of.
So I want to keep answering some questions here from you guys. This is from PVK saying, welcome back. Thank you very much. Glad to see I'm back. Can I explain Dear Moon more? Yeah. So 2018, if you want a fun video to watch, look up Dear Moon and watch the SpaceX presentation titled Dear Moon. And that was the first time that we saw Starship. At the time, it was still considered, it was going to be carbon composite construction and not stainless steel. It had 3 fins. That's when they put the 3 large articulating fins on the aft end of the Starship booster, or the Starship part, the booster, not really. And that's also when it was announced that Yusaku Maezawa, a Japanese billionaire, had purchased an entire flight around the moon. And we had already known in February of 2018, there was a press release that that someone had bought a flight on Falcon Heavy and with a Dragon capsule around the moon. But I think it ended up being like, hey, we're not going to be certifying Falcon Heavy for human flight. And why have it be you and one friend, which is all that Dragon could really do for that type of mission? Why not make it so you could do you and as many friends as you want? So he decided, hey, we're going to do this project where I invite artists. It's kind of like Willy Wonka almost, where he decided he's going to invite filmmakers, dancers, musicians, artists, et cetera, et cetera, et cetera. Social media influencers even. He's going to invite 12 people along with him to go around the moon with him on a Starship. And so he bought a ride on Starship, which, you know, in theory is actually even cheaper than a ride on Falcon Heavy. So, so he's going to be one of the first people to fly on Starship, likely with 12 people. And he's already invited a handful of people to join him. One of them, I forget the director, but a director had been invited. And there's now rumors swirling and speculation that Mr. Beast got invited as well, which would be very interesting. Oh, we have a hold, huh? Okay, little hold. Not a big deal. This this happens. This might be one of those mornings. This is from David Nagy. Well, you know, okay, so or Willis. I mean, yeah. David Nagy asks David Willis. I think bulbous end up flaming end down is not what we're probably going to be saying here. So, welcome, Spook the Gamer. Thanks for your membership, and also thank you, Teppo, earlier when you joined as well.
Well, thanks. Every time I see that video and watch the kids make their postcards, it's just
love it.
really,
Yeah.
I get a little misty-eyed.
Exactly.
And your kids are pretty great artists.
Yeah, they love to draw postcards. My daughter Rami, she loves to imagine what life is going to be like in space, and she's been kind of busy drawing some amusement parks and space colonies. It's really fun to watch.
Awesome. All you students out there, send us your postcards and we'll send them to space on the next New Shepard flight. All right, there's our beautiful rocket there on the pad. Gorgeous day. Nice clear blue skies. Great for that lunar landing sensor demo. We're at T-minus 2 minutes here. I don't know about you, but my heart is starting to race.
I am ready
Pretty
to see this
soon
thing
here,
fly.
we'll start to see some of the bit checks on the rocket. Just take a look at her. She comes alive for launch.
So, this is from Ben. Ben Lonergan saying, I have a question. Would I use Blue Origin or SpaceX to get to space? Well, it depends. Do you want to go to space or do you want to stay in space? Because currently the only vehicle capable besides the Soyuz and China's rocket is the Falcon 9 and the Dragon capsule. That's the only other way to get into orbit. This vehicle can just kiss space, and then because it's not at orbital velocity, because it's only going straight up and doesn't interject itself with
You can see
a
those
ton of
fins
horizontal
moving there.
velocity.
It's a
It
great
needs to go
sign.
17,500 miles an hour, 28,000
It's like
kilometers
on an airplane,
an hour
you test your
sideways.
control surfaces before you
In order to look at the control surfaces moving, that is awesome. In order to stay in orbit, you have to go that fast. So just getting up to space doesn't keep you there. You fall right back down unless you're going fast enough to basically be falling over the horizon the entire time. But I would honestly love, like, my commitment level to wanting to go to space. A year ago, I didn't even want to go to space. Now I could see myself on something like New Shepard because I don't want to go like anywhere long term. I don't want to like sit on the International Space Station and get in the way and ruin science experiments. But I would love honestly a ride on New Shepard at this point because that view looks amazing. But I'm going to listen in here.
turn it over to mission control.
Please, baby.
Godspeed. Have a great flight.
Let's do this. I'm ready to see this thing fly. Feels like it's been forever.
T-minus 20 seconds. T-minus 13, 12, 11, 10, 9, 8,
Finally,
7,
yes.
6, 5, 4. Command engine start. 2, 1.
All right, look at her go. Mission control has confirmed New Shepard has cleared the tower. Check out that shot from our drone. On her way to space. Lunar landing tech on board. Payloads inside. You can see at the top right of your screen there, New Shepard's gaining speed. That BE-3 engine is really doing its work. What a clean burn. First milestone here is max Q.
Comes up really quick on this vehicle. So just for reference, guys, when it gets to about 50,000 feet, that's how high Starship will go for the serial number 8 height. So this will give us a good sense.
All right,
of,
looks like the rocket has gone through max Q. That's when the aerodynamic stresses are at their maximum on the vehicle. Next up, we're looking for MECO, or main engine cutoff, just before separation. Beautiful burn on that
so
BE-3
about
engine.
here is when Starship would be hitting apogee and starting to fall back.
Coming up on 1,000 miles per hour.
In the next month.
It's a quick trip to space for New Shepard.
So it's now at 1,600 kilometers an hour for those of you that don't understand our the Imperial system. Screaming along there. $100,000 feet, so we're at like 30,000 or 30 kilometers or so, a little bit higher than that now. Still just screaming. So notice coming up on Miko.
Separation after Miko here. Looking for that engine shut off. There we go. Looks like BE3 engine is shut off.
And notice it's still going up, of course. It had a lot of inertia. So it's coasting up.
Speed's decreasing now.
Oh, you can
All
see
right,
separation.
I think I see separation there.
Still coasting up. Isn't that crazy?
Yep, you can start to see the distinct craft in your screen. And right about now, those experiments are getting their clean micro Gs. 3 to 4 minutes of hang time, gathering some great data. And at this point, if you were flying with us, you'd be able to get out of your seat, float around the capsule, do a somersault, high five your friend, and look down at that beautiful Earth below you.
So there we go. We're coming up on pretty much right there is 100 kilometers. Right there. So it has officially crossed the Kármán line.
Booster is starting its descent back to Earth.
To their altitude, their altimeter there.
Almost at apogee for the capsule.
Now watch, the speed will flip, and now it'll hit about 0 and then start speeding up because that means it's falling back down.
All right, apogee. As long as that's over the Kármán line, if you are an astronaut on board, you are now officially an astronaut, my friend.
So when 105 kilometers.
All right, now the booster's coming back down. Those sensors are really going to work as the booster makes its way back to the pad for that precise landing here in West Texas.
I love watching the booster land. The booster landing is awesome. They knock it out of the park. And don't forget, it can have a low enough thrust to weight ratio with its engine. It can deep throttle enough to actually be able to hover if they need to. So if they need to translate over and like do something like a maneuver like that, they can do that with the new Shepard booster.
The rocket's soon reaching the atmospheric pierce point.
So the rocket will
This
fall.
is when the rocket's returning from space and entering the atmosphere. And those control surfaces on the fins are starting to have air pressure against them for the first time on its descent.
And the booster's going to fall a lot faster than the capsule.
The rocket will come back and land on the pad just 2 miles.
Because think about it, it's a lot more it's a lot more dense, a lot more. When you look at the two, the capsule obviously has a flat surface, like the heat shield, and it re-enters with a large surface area compared to its amount of mass. The booster, on the other hand, is a lot more dense and even more aerodynamically pointed, so it's going to fall a lot faster than the capsule.
It's more aerodynamically shaped than the crew capsule, which is why it will win the race back to the ground and land a few minutes before the capsule, which is great for the astronauts. They get a little more hang time up there. You can see those wedge fins keeping the rocket stable.
It's screaming, but notice it's going to start slowing down just from.
We talked about that the LiDAR
pressure.
sensors are right below those fins on the fin box.
There you go. It's starting to slow down now, just from air pressure.
Soon here, we'll see the air brakes deploy.
And once those deploy, it really slows down.
This will slow the vehicle down significantly as it makes its way down. There we go. You can see the booster's speed is slowing down rapidly here as it gets closer to the pad. You were down in Texas, you'd hear a sonic boom any second, almost knocks you off your feet. It's so exciting. All right, there go the drag brakes. Here we go. We're getting close. Now we're just waiting for that BE-3 engine to relight.
All right, baby. Show us how it's done. Please relight. Okay, good.
There we go. All right. Come on, Shepard, let's go. Wow. Look at that stability.
So stable.
Yeah.
Touch
Oh my God.
down. New Shepard. Here we go.
I love watching that moment, like every single time.
I'm sorry if you can hear me pounding the desk and my mic, but
They
that
make that
never
look
gets
really
old to
easy.
watch that
They make that
rocket.
look really, really easy. They just do that so perfectly. That's impressive. I absolutely cannot wait to see them land a New Glenn, because that will be insane. New Glenn is 7 meters wide. That's going to be quite the sight to see. What is that, like 22 or 23 feet wide? That, I mean, it is a big, big, big rocket. That's going to be insane.
Yeah, somehow it knows how to go back there every time.
That's crazy.
All right, well, I hope those sensors got some good data today. You'll see in a minute the vehicle here will start to vent.
Wow.
And
I
our
love that.
recovery crews are
Wow.
going to be out there soon to safe the vehicle.
Finally, it flew again.
7th landing for
see the
this
capsule.
booster. What an awesome record.
Amazing.
Every launch, I think I speak for our whole team here at Blue Origin, that you feel like you're a little part of history, being a part
There
of
we go.
this era. Oh my goodness, here we go. Here's the capsule. Looks like the mains have deployed. They're unfurling. You can see the...
Now, I do want to point out, right when it touches down, it's going to look like the capsule slams down, because you'll see all this dust get kicked up. That's not because it lands hard. It's because it actually has retro rockets that they ignite for literally just like half a second to cushion. Because right now it's going 16 mile an hour. That's what, 24 or some kilometers an hour. So it's going pretty quick. You wouldn't want to just hit the ground like that. I'm sure you'd survive, but it wouldn't be as pleasant. So they intentionally light some retro rockets right before it lands to just null out that velocity, so it touches down extremely soft and like with almost on a cushion, and it kicks up a lot of dust when doing so. So just get ready for that. Pay attention. It's kind of a cool little feature. The Soyuz also does something like that too when they land on land, which is always, except for once by accident.
Wow, Joel, just a picture-perfect launch so far.
I love this.
And you can see the speed stabilizes about 16 miles per hour,
That's
and then
right.
we'll be at about 1 to 2. Here we go, almost touchdown.
Get ready.
Beautiful shot from our drone there.
Yeah.
So hard to gauge. There we go. The ground. See those retro rockets? Any second. It's just this tiny.
All right,
There
and
it is.
touchdown of the capsule. All right.
Wow, made it back. Excellent.
Woo!
Yep.
Wow, we got both our craft back safely from space.
You see
Looks to
those-
have been just a fully nominal flight here, Joel.
That's right. You see those parachutes gently falling to the ground.
Yep.
I'm about to fall out of my chair.
They definitely make it look easy, honestly. I mean, it's such a that's why I would honestly want to fly on this thing, is because it is such a simple profile. It's such a safe and conservative profile. There's nothing too crazy about it. It makes sense. I love that they're able to propulsively land the booster, and using just a simple capsule, safe, parachute landing with some retro rockets makes sense. The capsule even has an abort motor in it. If they were to have to abort from the booster. So it's just a nice, simple, elegant solution to a way to be able to do space tourism, but also to test their landing software, landing hardware, landing profiles, kind of practice the whole landing everything. The one thing I've always wanted to know, there we go, 351. Yeah, so about 105,000 meters.
Today. Crew capsule's apogee,
Only
awesome
10 minutes.
altitude, 351,200 feet. Max ascent velocity under that BE-3 engine, 2,232 miles per hour.
That'd
Wow.
be fun.
Mission start time 8:36, right on the nose. Great job, Team Blue. And mission time 10 minutes and 15 seconds. It only takes you 10 minutes to become an astronaut, Joel.
It's kind of incredible to think about, isn't it?
Wow. Of course, we'll be looking
So one
at
of
all this data.
one of the things that I want to learn is how do they make it so? Do they have to factor in the wind and everything, or do they have different landing pads just so they make sure that the capsule doesn't happen to land directly on the booster? I know the odds of that would be almost, looking at how big this space is, the odds of that are almost zero. But, you know, I wonder if they have to factor in, like, oh, the winds right now would make it so the capsule comes back, or do they translate really far away, you know, with the booster aerodynamically to get away from any potential of where the capsule lands? Let me hear real quick
Come
here.
join our growing team. We have locations all across the country, and we're hiring. Join Blue.
Awesome. And to commemorate today's mission, we always make a mission patch, don't we, Caitlin?
Yes, we do.
To commemorate.
Well, you do.
Well, yeah, my team works on these patches. We work with the new Shepard team as well, and the NS-13 mission patch is a special one. This was designed actually by the new Shepard team, along with the payload team that worked on today's lunar lander experiment that you saw. And it actually features New Shepard landing on what looks like both West Texas and the moon. It's actually, this one's cool. It features glow-in-the-dark thread to commemorate those lunar
that is
lasers
awesome.
that help us with the experiment. So to find that gear and other gear with the NS-13 mission patch on it, go to shop.blueorigin.com.
Awesome. There she is, right there. All right.
So
well, that's all.
we had a
from
little
here.
discussion in our Discord channel from Casper Stanley asking, can't they steer the capsule like you can with other capsules? Because capsules can actually steer through reentry. What they do is they actually angle the center of mass away from the center of lift. So imagine the big old heat shield. The center of mass can be somewhere, you know, if it's right down the middle and you rotate it, it has no effect on it. But, you know, if what they can do is they can actually put the center of mass offset from the center of the heat shield. And by doing so, it actually can generate lift. So by rotating, I have a video about how you re-enter and come back down from orbit. Definitely watch that. It kind of talks about especially how Dragon does it. But if you want to learn about how you can steer a capsule, they can just rotate like this. They can do 180-degree turns just to null out. So if they're right on target, or if they need to like dip in further or steer, you know, left and right, they can do a little bit of that. But I mean, they maybe can do a little bit of that, but on this, but it's not a very big effect. And it's really just to help target a large area of a landing zone as far as like reentry. And stuff like that. So it's not, I don't think it's anything that they can really utilize too effectively here. I think it'd be a very limited effect. So I am kind of curious how they make sure that it doesn't interfere with the booster at all on landing. Yeah, if you guys want to, by the way, thank you for Discord. Hey guys, how are you guys this morning? If you guys do want to join our awesome Discord community, you're going to see me losing my mind right now as I try and detangle Soviet rocket engines because it's what I've been doing now for a while, not as long as Ghost Rider in our Discord channel, who has helped really, really do a phenomenal spreadsheet, but now is trying to tell the story, which the story of the Soviet engines is the most confusing thing I've probably ever worked on. If you guys are ever confused about like, oh yeah, the Antares, they use, you know, just N1 rockets, well, or N1, you know, motors, the NK-33. Well, they did until those blew up. So now they use the RD-181. Oh, you mean the same one as the Atlas V? No. That's the RD-180. That has two chambers. The RD-181 is a single-chambered version of the dual chamber. Oh, but isn't the RD-180 just already a four-chamber version of a two-chambered version of the four-chamber RD-170? Yes. Like the actual naming scheme is the most confusing thing in the world. So I'm going to be breaking it all down for you guys. Don't you worry. But I'm good. So that's the video I'm working on right now. I'm going to be streaming tonight, late tonight, my time. After midnight Central, there's going to be a Soyuz launch tonight. And this is going to be the first time I stream a Soyuz vehicle because I finally kind of know enough about it to talk about it more candidly. So I will be streaming tonight. It's a launch with astronauts on it. There's 2 cosmonauts and Kate Rubins from NASA will be flying to the International Space Station. So I will be streaming that late tonight, guys. So hopefully you guys can join me tonight if I don't lose my mind in the meantime trying to dissect Soviet rocket engines. Yeah. Also, if you guys want, I did see some people asking. We are doing the launch day code. If you guys want 10% off of this T-shirt today, it's the Aerospike T-shirt. We don't have the black one anymore. We might release that again on the 1-year anniversary. But if you want to take 10% off of the Aerospike engine T-shirt, use coupon code LAUNCHDAY, all one word, all lowercase, at shop.everydayastronaut.com. And friendly reminder, we do have the new full flow stage combustion cycle hoodies in. These are absolutely incredible. Tons of details. There's, like I said, there's even an Easter egg that no one's actually found on the hoodie yet. But they're really cool. Get these now if you want. There's also new keychains, a Future Martian t-shirt. We have face hole cover, not a masks for sale. All the fun stuff. If you guys want to help me continue to do what I do, just go to shop.everydayastronaut.com. But we have a few more questions to answer here before we tune out. So Ben, back to your question about would I choose Blue Origin or SpaceX to go to space? I always forget I have to hit transition. My bad. But yeah, if you guys, if as far as Blue Origin, right now I would love to fly on New Shepard. I still would be a little bit hesitant to, go into orbit for like weeks or months. Like, no, thank you. I would maybe go into orbit for like 2 days or something. Just a nice little orbital ride on a Dragon capsule I would consider doing, but I don't want to go up for a long time. I don't know. I would love to see out the cupola, though, on the International Space Station. That would be pretty amazing. But I don't really have this desire to spend grand amount of time. New Shepard just seems like a fun way to do that. So let's see. If I try to get an interview with someone from Blue Origin, Ryan, I have kind of talked to the comms departments a few times, and I really want to get a very open interview. Like, I'd love to have candid where I could ask a lot of questions. That's the problem, is they're just a very secretive company. They don't really update us on a lot of things. So honestly, I feel like it'd be kind of, unless I could talk more openly about some of the capabilities and stuff of New Glenn, I don't know if it'd be that worthwhile of an interview, because I feel like we just kind of hear some talking points that we see in like the press releases and stuff. So I'm working on it, though. I would love to talk to someone at Blue, especially just kind of ask them about more about New Shepard, more about New Glenn. But yeah, we'll see. Chris, please ask Elon for more tank cams with zero-G fluids. Well, just so you know, those are not supposed to happen. Those are engineering cams. They used to show them a little bit more often, but there are technologies when you see. So sometimes you'll notice a really quick shot on a SpaceX stream that looks like an alien spaceship. It's like circle, circle, circle. It's all kind of blue. You see this fluid moving around. That is the liquid oxygen tank. You're seeing liquid oxygen, which is really cool, literally. And it's just floating around there. But there's a lot of intellectual property involved in how you prevent fluids like that from sloshing around in the tanks and all this other stuff. So it's not something they intend to, it's not an ITAR problem, but it is something they do not intend to necessarily share publicly. So I don't think he's going to want to add the tank cams intentionally. We'll put it that way. You can see through windows. No, but that is the thing. I know, like, it is kind of a maybe they get excited about features like Windows, but frankly, if you're going to be spending, who knows, I'm guessing over $200,000 a seat. I have no idea yet. They have not published it yet. But I'm guessing if you're going to spend that kind of money, you would want, the window size would matter a lot, because that's what you're paying for. You're paying for that view, so, and that experience. So, let's see. This is from Flo. Is European fulfillment for your shop still on track for the holiday season? Yes. Will be for all items size asking for a friend. Yes. So for those of you that don't know, we are working on a solution for cheaper, better European shipping. We were pursuing for a long time the option of trying to get a separate European warehouse for our merch. That is a logistics nightmare at this point for a shop our size. It just really almost cannot pan out any way reasonable at all. So we're working with a logistics company that will be able to provide basically the goal is at least two of the three things. It needs to be shipping needs to be cheaper than the shirt. Like, duh. It also needs to take less than a month. Duh. And it needs to have door-to-door tracking. Duh. Like, these are three things that, like, I absolutely cannot believe are not the norm in the store now when we use USPS or even DHL sometimes. It's insane. We absolutely, the goal is to have at least 2 of those 3 things significantly altered. So for sure, like door-to-door tracking. So the problem is a lot of times, like with our store previously was USPS. When it ships out, it'll just get stuck in customs, and it'll show the last point of tracking for USPS, for the United States Postal Service, would be the port that it leaves. So it'd be like, hey, your thing's in Los Angeles, and really it's been sitting 10 blocks away from you in a customs center in your hometown or whatever. It was the stupidest thing ever. The logistics company we're working with will have solutions for all of that. So it'll pre-manage all the customs and have door-to-door tracking. And it should take, shipping should be days, like couple days, 3, 4, or 5 days, and not a week to get there and then weeks of being stuck in customs before you know anything about it. I just think it's the silliest thing ever, and it's been just a pain in the butt. So we're working on it, and we're still on track for the holiday season. So Shandathe says, don't think New Glenn can afford the fuel to land quite that slowly. It's true. Hovering is actually inefficient. Hovering like that is not necessarily, as far as a performance standpoint, a good thing. But, if you have those margins built in, then go for it, especially if it's a smaller payload or something, and you're using a much more capable rocket and you're only using half of its performance. If it can hover and it needs to, that's not a bad thing to be able to have as an option. So, Turkal says, couldn't you stay in space if you fly right up and keep going? At some point you would get out of Earth's gravity. So just, yes and no. I mean, yes. Well, technically you'd actually never escape Earth's gravity ever. Even if you're on the opposite side of the universe, you would still be experiencing some of Earth's gravity. It's just going to be absolutely not even microscopic, just so insignificant compared to all other gravity vectors near you, basically. So, gravity is a gradient, basically. It goes out. I believe it follows the inverse square law. So if you go twice as far away from a body with gravity, you actually experience 1/4 the amount of gravity. So eventually you can get to the point where your sphere of influence becomes the sun or the moon, potentially, if you did fly straight up. However, that is a terribly inefficient way to try to stay in space. I don't know how many times. It might be 2 or 3 times the amount of energy to do something like that compared to just going into orbit first. So that's yes, you're not wrong, but could you do it that way? I don't think that'll ever be done, just because it makes no sense as far as from a physics standpoint. You're just constantly fighting. You're having to fight gravity drag the whole way, and not taking into effect any like the Oberth effect or any of the things that help you out really when you're in space. So hope I answered that okay. I'm sure there's some physicists screaming. Matthew Duggar says that would be the best 10 minutes of my life. I know. See, that's the thing, is I would like that to be so quick. Like I said, although I would love to be able to be weightless for like 10 minutes. I think that'd be cool. 4 minutes of 0G. I don't know. I don't know if that'd be enough, but but it would be incredible. The ascent and everything, I think, would be amazing. Yeah. Sandy, at this point, I think I would prefer blue, honestly. At this point, although I gotta say that the renderings and stuff that we're seeing now from Virgin Galactic. Although, why do we have renderings at this point? They've been doing this for like over a decade. I really wanted to see some more hardware for their new launcher, but or for the new spaceship too, I guess. But the huge windows on New Shepard are very appealing, and I really do prefer a parachute landing and having an abort system. I think those are nice features to have. I think that I really think new Virgin Galactic's vehicle will be very, very safe long term. I trust the engineers are doing their job and diligence to make it a very safe flight. But I do like having redundancy and having backups and having options. So for that reason, I think I'd prefer Blue Origin. But yeah. Grant. You're the first person to notice. You are the first person to notice. Yeah. We hid full flow stage combustion, or FFSC, on the end of the drawstrings on the hoodie. Yes, we did. Yes, we did. Good job, Grant. You win today's brownie points, Grant. John Beert, are you not okay with... am I not okay with using the bathroom space? Oh, no, I could use whatever bathroom is given to me. I could use a diaper, a maximum absorbency, a maximum absorbent garment or whatever. No problem. That does not bother me at all. I'll do whatever. It doesn't matter. It's more just like, I don't want to just like aimlessly float around. And I'm not like daring enough yet to explore. If, especially on like a risky vehicle that's relatively untested. If it's something that's like super normal, if there's, again, Starship someday just routinely going back and forth to the moon, you go out, hang out on the moon for 2 weeks, come back, awesome vacation. Yes, I will do that. But until that's like routine and proven out and everything, like I don't want to be on the first dozen flights, period, of anything. Let alone the first probably even 100 flights, just historically, like I feel like it takes about 100 to really shake things out and understand your risks and everything and your actual vehicle well enough. So yeah, it's not a matter of bathrooms. It is definitely just a matter of purpose and safety for me. So this is from Santiago, says, "Hi Tim, where do you get your rocket engine models?" Yeah, I have all over. The Falcon Heavy and Falcon 9s are from Oliver, from Buzz Space Models, or Ollie Braun. Thank you, Ollie, for the buzzspacemodels.com are those ones. This is a Lego Saturn V here. The Blue Origin stuff, including the new Glenn and the new Shepard that I have here on my desk, are from Blue Origin. The Electron here from Rocket Lab is from Rocket Lab. These guys here, these are from, you guessed it, ULA. So, there's a little remnant of our chat system sticking around there. Hey, it's floating. So those are from ULA. These are actually signed by Tori Bruno. That's surprising. I had no idea that was going to happen when they showed up. I was just like, are you kidding me? That was awesome. Super stoked. And that's just some small, I don't even know why I have that small Saturn V there. I feel like I should move that since there's already a bigger. I wish these were all to scale. These are not to scale with each other, by the way, guys. As a matter of fact, the Delta IV Heavy should be 2 meters taller than Falcon 9 and Falcon Heavy. Specifically the Falcon Heavy with the fairing, which is 70 meters tall. The Delta IV Heavy is 72 meters tall, so it's about 6 feet taller, 6.6 feet taller. And it'd be, I wish they were to scale, and especially like down here, the New Glenn would be massive. It would dwarf the first stage of New Glenn. So right there to the grid fins, or like right this little ring, that would be as tall basically as the first 2 stages and a little bit of the fairing even of Falcon 9 and Falcon Heavy. It is huge. I really wish they were all to scale. And the Electron would be tiny. The Electron would be like the size of one of these boosters here. I really wish they were to scale. Someone one time said that I should try and align them in the studio to actually still represent scale. Ain't nobody got time for that. Sorry. And Sebastian, I just answered that question too. Yeah. So hopefully that helps you guys know where I get them all from. Richard Jenkins, my company is developing a new method of manufacturing much higher melting point for metals. What metals would you like to see us focus on for space? Well, stainless steel is a very common metal for space. It's been used in the Centaur. It's obviously being used by Starship. If you could figure out a manufacturing method that increases the melting point, I would focus on 304 stainless steel, basically, and 300 variants of stainless steel. I think if you have a technology like that, that could be extremely helpful to certain industries. But as far as high melting points for space, now you're just talking about re-entry, really. That's the only, and a little bit of entry. Like you'll notice on Ascent, the tip of like some fairings have a little bit of a different metal there, like a titanium or something to help have higher temperature resistance as well. So you might want to look into titanium as well, but otherwise you're only really talking about re-entry if we're worried about high melting points. And in which case, the only things that we're really talking about there, normally there's an ablative heat shield people are worried about, but an aluminum, what's that one? I don't know. Look up aerospace aluminum would be one, but I would honestly, the only one that really, really matters in that case is probably stainless steel. That's what I'd look into. That'd be something presentable for sure. If you're like, hey, by the way, we made it so you could handle 200 more degrees Celsius of peak temperatures or something before fatigue, yeah, that'd be pretty substantial. So yeah, that's awesome. Edward says, Shepard is great, but it won't take Tim on Mars. I don't want to go to Mars. Please don't make me go to Mars. Please don't go to Mars. Oh, Casper Stanley also says in our Discord that Copenhagen Suborbital uses 304L. Yeah, yep. So that's I love that Copenhagen Suborbitals is doing a lot of stuff that Starship is doing, so you can learn a lot about what they're doing with Starship because they're also using a lot of the same materials, and they're very open about it because it's open source, so it's super cool. Let's see. What's my opinion on supersonic aircraft, the Project Boom? I think that's going to be great. I really want to see passenger supersonic vehicles really bad. I want reduced travel times really bad. I really want to be able to get, say, to New Zealand in under the shortest flight basically is like 13 hours. It just sucks. Like I want, if that could be half, it could be 6 hours. That'd be no big deal. I go to Europe. I don't go to Europe right now. I would love to go to Europe in just a couple hours, like 2 or 3 hours would be amazing. But yeah, I think that's awesome. The Project Boom so far, all they've released is basically just a technology demonstrator. It looks like it's not it's just their first supersonic aircraft. It's not a passenger vehicle yet, but more just a kind of a study, which is cool. That's great. That's a great first step. This is from Tim Bow. Its main engine failed, lost thrust early. No, Tim, you can't conflate. Obviously, it hit its metric. It went over the Kármán line. It went 105 kilometers. So its main engine did not fail. We can't. The timing of like the sidelines and telemetry and the cameras. There's always like seconds of delay between those systems. That's the biggest thing is actually normally the cameras have like a 3 to 7 second delay to get from the cameras to the producer. So lots of times the cameras might be ahead or behind or whatever. And if they had to factor in delays normally, you can talk to Andrew, my producer, about this, factoring delays between the different cameras feeds and stuff so it all lines up. And that stuff can be off and is off all the time. So it went what looked like absolutely completely nominally. If the engine had shut off early, it would not have crossed that 100-kilometer mark just based on physics. And obviously the engine didn't fail because it would not have been able to relight and land safely. So I don't see any reason why it seemed like the engine failed and why it would seem like the flight did not go perfectly well based on the numbers. So, yep. Well, guys, that's going to do it for me because I'm going to get out of here so I can continue working on my next video because that's going to be awesome. Like I said, it's detangling the lineage, the history, the evolution of Soviet-era rocket engines, some of the best engines ever made still to this day ever. If you want a sneak peek on that, you can and hop over into our Discord. You can do that by going to patreon.com/everydayastronaut. Thank you to my Discord members, and thank you so much to my Patreon supporters for helping make all this possible, including we are stepping up our game big time for serial number 8. I will be down. I'm going to Texas for serial number 8 events. Andrew built out a flight case. So people always say, like, why don't you do this? We have backups on backups on backups and a full-blown mobile studio that we're going to be taking down to serial number 8. And we are going to run one heck of a show for you guys. I guarantee it. And it's going to be hopefully bulletproof. But yeah, so that's all thanks to Patreon supporters for helping me, allowing me to be able to reinvest in everything we do here and just make it better and make better products, make better videos, spend more time making awesome videos instead of just rushing stuff out, because that's not what I do. Quality matters. Quality over quantity, and accurate information over just speculation. That's what matters to me. It's kind of it's the motto I live by. I think that just matters more than trying to rush something out arbitrarily. So yeah. Well, guys, yeah. Is it, Andrew, is it actually bad? Don't tell me that. All right, guys, that's going to do it for me. See you tonight. Remember, I will be streaming the Soyuz launch tonight. So join me late in the United States or really early in Europe, or just in the middle of the day if you're somewhere else, I guess. I don't know. But hopefully I'll see you guys tonight for, what is it even? I don't even remember. Is it MS-17 or something? I should probably know before I stream it, huh? It's, yeah, MS-17. So join me for that here in about 15 hours from right now. It's going to be my first Soyuz stream, so wish me luck. And that's going to do it for me. I'm Tim Dodd, the Everyday Astronaut, bringing space down to Earth for everyday people. Goodbye, everybody.